In this tutorial, I'll be showing you how to use one of the onboard switches on the Launchpad to control one of the onboard LEDs. So as you can see, we have a switch here on the bottom left of the board. This is switch 2. If you take a look at P1.3 in parentheses, you'll see S2, meaning that that pin is tied to this switch. This is switch S1 and is the reset switch, which can be used as an input, but it takes a little bit more work. So for this, we'll just be using this switch and one of these LEDs. Now, low quality switches like this on the Launchpad have issues with bouncing. So this graphic shows there's an off period on either side here and an on period where you've pushed the switch, and there's a bounce period in between. So what happens is you push the switch down, and as it's making contact fully with the connector, it's fiddling back and forth between the off and on state here, and as well when you let go. So there's a way to fix this in code, and we'll be going over that. So go ahead and move to a text editor and create a new file. We'll call it butt pull for button pulling, and include the MSP 430 header, and open up your main method here. Go ahead and calibrate the watchdog timer, or hold the watchdog timer and calibrate the processor to 1 megahertz. And then from here we want to enable one of the pull-up resistors for the switch. So bit 3 is the same as, putting in this number. Oops, excuse me, 0, 1, 2, 3, this number. And these are constants that are defined in the header file right here, as well as all of these register values. So this is just a shorthand way of saying you want this particular bit on for the pull-up resistor. What the pull-up resistor does is, instead of having the voltage on the pin floating between 0 and 1, it pulls it up to a solid 1. So as you saw in this picture, instead of having our off and on be 0 and 1 like this, what we really have is something more like this, where our off period is when the voltage on that pin is 1, and the on period is when it is 0. So this is referred to as a active low button, because when you push the button, the voltage goes low. Okay, now that we've done that, we can go ahead and set the output for that to be 1, as well as set the direction for the LED to be an output. If you remember from a previous video, all of the pins are considered inputs until you expressly set them to be 1. So here I'm using shorthand bit 0 again, which is the same as that number right there. We'll go ahead and open an infinite loop here. And inside we will want to check if bit 3 and the P1in register are equal. So what this is going to do is do a bitwise AND between the P1in register, which is a read register, to see if the voltage on pins have changed, and bit 3, which we know is this number up here. So if this is 1, this will be true, but we're going to logically not it. So if it's 1, it will be false, and if it's 0, it will be true. So we know that we're setting, this is 1, and we're setting the output here on that pin to be 1. So these will be equal when the button is in its resting state. So I'm not touching it, these will both be equal. So we're going to have a 1 result here. And we're going to logically knot that to a 0. So this will be false when the button is not being pressed. But when I press the button, P1in will go to 0, and then these will be unequal, and this will cause that 0 to be a 1, meaning this will be true. So this code is only going to be executed when I press the button. And inside we just want simple toggle of bit 0 to toggle the light, the LED on bit 0, this red LED right here. So go ahead and save that, do a make flash. As you can see, nothing's happened, but if I go ahead and press the button, it will toggle the LED. Now you notice it has a weird behavior. If I hold the button, the light seems to get dimmer, and sometimes when I let go it will be off, and sometimes when I let go it will be on. Now the reason for this is that this for loop is running very quickly. We're calibrated at 1 megahertz, so 1 million cycles a second. It's doing this very fast and checking this every time. So when the button's held down, it's continually toggling that LED back and forth, and that causes it to be a little bit dimmer. And then if I let go at the correct point, it's going to be off or on, depending on what state it was in. So to fix this, we can add a little while loop here. Where we just check when this is down, we'll get caught in this while loop and nothing will happen. And when it's up, this will be false and it will break out of this while loop. So go ahead and save that and flash it again. And now we have a little bit more expected toggling of the LED. But we still have the debouncing problem. So sometimes I'm pressing the button, and when I let go, it's bounced to the point where it goes opposite of what you would expect. Like that. I press the button and it still went back on. So to solve this issue, we can add a small delay here before heading back into the infinite loop. And we'll just delay for 32,000 cycles, which at 1 megahertz is going to be 32 milliseconds. Go ahead and flash that back to the board. Now we have a little bit better behavior with the button, where it's toggling more reliably between the two states. I can even press it pretty quickly and it will still go back and forth. There you have it. This is button polling. So this is a kind of bad way to check buttons to see if they're pressed or not and to cause something to happen. A better way would be to use interrupts, which we'll go over in the next video. But for a simple program, just to pull on the button to see if it's down or up, and then toggle an LED based on that information, this is an easy way to do it.